Okay, I want to talk a little bit about this problem we had from class, which was to graph f of x is equal to 3, and then the greatest integer function of 1/2 x minus 3. Okay? Or I think your book is using this notation 3 int 1/2 x minus 3. Okay? So the first thing we need to do, and I'll do it, those two methods that we talked about with both the t-table, and just using this graphing and kind of a more intuitive understanding, or seeing them as transformations of the graph. So, but the first thing you absolutely need to do either way is to know what the base graph looks like. And this greatest integer function is this step function we talked about. Closed circles on the left, open circles on the right, and it would take these steps up like this. And same thing this direction. It's the greatest integer less than or equal to the number x, okay? And it continues in this pattern. So if I want to get a table of, or a list of t-table values, I want to identify important points. For example, these two endpoints and noting which one is closed and which one is open is probably going to be helpful. And maybe this next step, maybe those 4 points will honestly be enough for us. So let me write those down here. And I'll use these x and y values. So for the x values, I have 0, 0, and maybe that I'll put open or closed because I want to keep track of that, right? And that's a closed point. The point 1, 0 is on, but it's open. The point 1, 1 is on the graph, it's a closed point, and the point 2, 1 is open. Okay, does that make sense? So kind of keeping track of where these points are. So here's my points again, x and y. 0, 0, 1, 0, 1, 1, 2, 1. And this one's closed, open, closed, open. Okay, so now when I look at these points and I think about, again, this function, 3 int 1/2 x minus 3, I think I identify 3 things that are happening. One, I'm going to horizontally stretch by 2, the reciprocal of this 1/2. I'll also vertically stretch by 3, and then shift down 3. Okay. Now this first step affects inputs here, and these last two affect outputs. And so you'll see that here in my t-table. So here, when I want to do this t-table, these x's now become my nice points, and they'll end up being whatever 1/2 x is. Because I want this piece right here, the full input, to be these points that I already know the output of. Okay? So in this full input are these points that I know, 0, 1, 1, 2. And when I put those in, this output of int of 1/2 x is a 0, 0, 1, 1. And these are closed, open, closed, open. Okay? Okay, so now to get to 1/2 x, the point that I need, the real x value that I'm using, to get there from here is like I solved this 1/2 x is equal to 0. I want 1/2 x to be 0, and when I solve that, I get x equal to 0. So that is that real input. When I solve 1/2 x is equal to 1, I get x is equal to 2. You get this stretch. Okay? Same thing here, and here this one should be 4. Okay? So this is my real, right here, real column of inputs, because nothing else is happening to my inputs. Okay, so now I'm going to go over and make some other columns of outputs. And I'm going to come over here. Now, I have to vertically stretch this by 3. Once these values come out, they get multiplied by this value 3 here, right? That's at the front. Okay, so now this next column is this 3 int 1/2 x, okay? And these outputs just get multiplied by 3, so the ones that are 0 stay 0, but my next ones become 3. And then everything gets shifted down by 3, which I think won't actually change this graph, right? So these go -3, -3, not that much maybe. Maybe just a little bit. And these go to 0, 0. So my final columns of inputs and outputs are right here, column 1, and this last column. So if you want to go ahead and put those down on a graph, let's see what that graph looks like, okay? And I also want to keep track of these closed open points right in here. Okay, so I'll bring those down with me. Okay, let me get a graph here. Okay, so I'm going to put these points on, and then I think we'll be able to see. So the points that I have are 0 and -3, and that should be closed. And then 2 and -3, and that should be open. And in between here, I know there's my step, right? And then the step goes up, and it's at 2, 0. That one's closed. And I go to 4, and that one's open. So you see kind of this, the length of this step is 2, and the distance between them is 3. I can get kind of the pattern going here. 1, 2, 3. Here, go over 2, open, 1, 2, 3, close, go over, and open. Like that. You can come down 1, 2, 3, and over 2. And you should get some pattern like this, right? Where there's a distance of 3 between the steps, and then the steps have length 2. Okay? Now, I want to also do this. That's the T-table method if you want to do that method. So let's also go ahead and do this on just a graph. And so the graphical method, I start again with the same sort of list. This list of things that I know is going to happen. That is horizontal stretch by 2, vertical stretch by 3, and shift down by 3. Okay? Those are the 3 things that I want to do, and also in that order. Okay? Let's do this graphically, and I want to do it in a series of graphs that I want to draw here for you. So let's do that. Let me draw just a few graphs here. So that you can kind of see this sequence of transformations all together on the screen. Okay, so I have these graphs. My original graph looks something like this. Steps of 1. Okay, these are closed circles on the left. Okay, and then this first transformation, horizontal stretch by 2, takes every point that's not on the y-axis and it will stretch it out. Okay, so these 2 points that lie on the y-axis are kind of this open, this 1 point closed circle, and then this open kind of placeholder. Get there, and the rest of these, this original point, let's say 1, 0, gets stretched out here to 2, 0. I stretch it away. Now then this point here at 1, 1 gets stretched, and the x value becomes 2, and then that final value out here is 4. So I get this horizontal stretching like this. And you see these steps lengthen. Okay? Now vertical stretch by 3 will again stretch everything away from the x-axis, and it will stretch things apart by a factor of 3. Okay? So this piece that lies on the x-axis doesn't change, but my next step does. It originally had a y output of 1, that now jumps up to 3, and still has the same length. Down here, this original output that's at -1 goes to -3. So you kind of see these steps get bigger in the distance between them. And then I'll just shift everything down by 3. So this original piece here, let me just lengthen this graph a little bit. Minus 6 is right there. This piece here that starts at -2 and is at 3, 1, 2, 3, 6 goes right here. Then I step up 1, 2, 3, and here's my step. And then my next one, this step here that starts at 2 is now at 0, because everything got shifted down. And you can continue this pattern 1, 2, 3, and get this next step here that begins at 4. Okay? So, but again, these graphs should look the same. This should be what your final graph looks like, but please let me know if you have any questions about this.